Good morning, ladies and gentlemen. Today we're going to look further at probability distributions, and remember last video we looked at the mean, or the expected value, and that had a summation notation that was quite simple. It was the outcomes each multiplied by their probabilities added together, and that gave us a measure of what the center or the average outcome would be from this distribution. Today we're going to take that and take it a little further and look at not only how to find the center, but how to find a measure of spread. So what's the average spread of the distribution? How varied is it? And we measure how varied it is with two different measurements that are, well, the same but very much related. One is called variance, or Varx, denoted as rho squared, or standard deviation, which is the square root of that above. Alright. Now, doing these by hand is a pest, and relatively rare, fortunately. But still important to see. So, here, you need to find, if you're asked to find the variance, you still need to find the mean first. In the question here, it asks us in the order we get them in, so let's follow that order. Find the mean, we do each outcome multiplied by its probability, and then add it together. Don't know why I switched those last two around. Okay. And of course you can grab your calculator here, but if you're asked to do it by hand, chances are they're going to make you do it in your head. So that's 0.3 plus, did I say 0.2? I meant just 2. 0.8 plus 0.9, which is all going to equal up to 2. And that shouldn't be a huge surprise for us, because if we look at this carefully, we can see that 2 has an average of 0.4, and then 1 down is 0.3, 1 up is 0.3. So the balance, or the middle here, does feel about 2. Alright, we have an average of 2. Now, variance. To find the variance, we do the sum of xi take mu squared times pi. So what that is telling us to do is for each value, we do 1, which is this one here, take the mean, that one there, squared multiplied by the probability of that value, 0.3, plus. Now, second one, 2 take 2 squared times 0.4 plus 3 take 2 squared times 0.3. Now, I think it's worth pointing out a few things about this formula. Firstly, the mean isn't going to add anything to it, because the value take itself squared is 0 squared is 0, that's going to come out as 0. What that represents is if the mean is one of the values, and it doesn't always have to be one of the values, but if the mean is one of the values, it doesn't contribute to the variance at all, because we're looking for variation from the mean. The mean doesn't contribute to the variation from the mean, so it doesn't play a part in this formula, which is why that bit drops out to 0. This here is 1 squared, 1 minus 1 squared is 1, so it just becomes 0.3 plus, and this here, same sort of argument, 0.3. This whole thing here is 0.6. The variance is 0.6. Okay? And the variance can be written as mu squared. Lastly, the standard deviation is the square root of that. So standard deviation is the square root of 0.6. Right. Now, doing these by hand is relatively rare, but it's important to know how to do. And note how it says, check your answers using technology. Using technology is by far the more common way of doing this. So, going down here, we're going to find these same things using technology, by calculator, or CAS. Xi, probability of I, and clearly with those numbers, doing it by hand will be tough. So, we grab our calculator, and what we do is we enter two lists. In list 1, we have the outcomes. In list 2, we have the probability of those outcomes. And then we go calculator. And here, we need to make sure our settings are correct. So in the settings, we want the x variable list to be list 1. And what we want here is the one variable frequency list to be list 2. So have it setting like that, list 1, list 2, exit, and then click 1 var variable. And what this is saying is that x bar, sorry, I meant to keep that up, x bar is 2.39. X bar is equal to mu is equal to 2.39. Now, if we look at the distribution, let's look at where it's weighted. 2.39 is about here. It's in between 2 and 3. That's fine. If you look at that, that's more than 50% of the probability down here, and that there is less than 50%, but there's some extreme values. So if you're trying to judge where the mean should be in your head, you can think of this like a seesaw, and you can think of each one of these probabilities as the number of bricks on different points on the seesaw. So, for example, if this is the 0.23 is that, 0.38 might be bigger, 0.21 is going to be a bit less than 0.23, but still as wide, 0.13 will be less again, and 0.05 will be much less. So the question might be here, where do we draw the fulcrum, or the bit to balance the seesaw? And the bit to balance the seesaw is going to go somewhere around here, because we know that if you've ever been in a seesaw, the further out you go, the more weight it applies. So the further out, the more it drags the average up that way. It's just like using mean in statistics. The extreme values affect the mean. Here, 5 is almost an extreme value that helps pull the average up from just being bang on to 2.39. So up in here. Alright, other things here. The other thing we want to look at is x rho n. That little symbol there should tell you it is the standard deviation. So that one there is equal to 1.12156. 1.12156. And the variance we would get by taking that and squaring it. 1.12156 squared would get us some value. Alright. So get used to setting up those settings in CAS. We use it far more than by hand, but you also should be happy using the formulas up above. I think that was it. Alright, enjoy. I'll see you tomorrow.